Hello students, hope you are doing well. Today we are going to solve one analysis problem on in Lisa software. So there is 1D bar element and we have to do the structure linear analysis. So question is determine the nodal displacement and the stresses of 1D bar with uniform cross section as shown in figure using elemental matrix equation. The length of the bar is 100 mm and the area of cross section is 150 mm square. The value of Young's modulus is 200 Newton per mm square and the Poisson's ratio is 0.3. The bar is fixed at one end and it is force 100 Newton is applied to another end. So 100 Newton force is applied to this end and it is fixed. Now here if you say its cross sectional area is 150 mm. So if we consider that if that bar is a circular cross section, so what should be the diameter? So that area is 150, pi by 4 is equal to d square. So the diameter would be 13.82. Now we are now we start this in the Lisa software. So in this is the Lisa software. This is Lisa 8.0 version. So now we are going to start the structural analysis of 1D bar element. So first click on the select analysis here, edit. So here we are going to select the 2D statics. Okay. Next, now we have to create the nodes, new nodes. So we have to provide the coordinates. So first node is at 0, 0 and 0. Say add. So you can see here red dot is added. Another node is at 100 because the distance is 100. Add. Say close. Now next is if you say here fit to screen, you can see here one element is here, another node is here. Now next, now we have to add the this new element to this geometry. So here new element. So here in this new element we are going to select the beam and here we have to write down the nodes that 1 comma 2. So we are going to select one beam and say add. So you can see this beam is added. So next is close. Now next is, so for this beam, okay, that element we have to apply the material. So we will going to select element, assign new material. So here in the assigning material we are going to see what is the geometry. We are going to consider circular bar. So its diameter is say 13.82 that we have already calculated. Next, what are the mechanical properties? Say it is a isotropic, its Young's modulus is 200 and its Poisson ratio is 0.3. So close this window. So material is get added. Next is, so we have to apply the load constraint. Okay. So here I will click on this select node. So this node is selected. Click on this select phase and here in load and constraint new fixed support. So it is going to create from the current selection. Okay. So you can see this fixed support is applied. Next is we have again apply to the force. So here I will select here select node. I will select this node, then select the phase, then here load and constraint new force. So the force new force, so force is in x direction and it is 100 Newton. Okay. So okay, so you can see force is also get applied. Now next is in the solution, click on the solve button. So once you say solve, it will be get the solver will solve the equation. Now You can see what is the x displacement, 3.333 at this point and 0 at this fixed n. Y displacement, no, there is no displacement in y, z. Okay, now you can get the this then longitudinal stresses. Okay, so stresses displacement you can get. Okay, so here in table you can see this table. In this table we can get the x displacement. Select all, say x displacement, update. You can see the x displacement here. If you want tensile force, update, so it will be tensile force is 100 newton because it's throughout the board. Next law, what is longitudinal stresses? Sorry, longitudinal stresses, you can see. So this is the longitudinal stresses that are developed in the point, and 3.3 is the deflection. Okay, change in length of the rod. So this problem is get solved. We can write the solution in the CSV file also. Okay, here if you write CSV file, it will get solved. Say element values also we can check, update. So these are the elements. One element is there and there are two nodes, 1 and 2, that those are the local nodes. Okay, then material also if we apply, it is again going to show the materials. Nodal coordinates also we can update. You can see first node 0 0 0 and second is 100 0 1. So in this way we can complete this task. So thank you for so you can here make it, you can visualize it here. Fit to screen, you can get it, zoom in, zoom out. Okay, so if you want the show node number, so you can see this is the node number 2, and if want to see, so that is another node, that is node 1. Again here we can show load and constraint. Okay, that is also we can see. So here we can complete this. Thank you.